And there it is. Now I'm going to show you how to run an existing netlogo model. Netlogo comes with a library of existing models. You can go to it by going to the File menu and choosing the Models library. And you can look through all the different disciplines and different models in each discipline. I'm going to go to Biology and go to the ants model. And you can read this in this project, a colony of ants forages for food. Though each ant follows a set of simple rules, the colony as a whole acts in a sophisticated way. So let's open that model. Okay, so the first thing to do when you open a new netlogo model is to go up here to the Info tab. Notice there's an Interface tab, Info, and Code. So the Info tab tells us a little bit about the model. Okay, and so it talks about how it works, how to use it, things to notice about the model, some ideas for how you might extend it, etc. So you can take a look at that yourself. I'm going to go back to the interface, and you'll notice that there's two buttons here, Set Up and Go. Those appear in most netlogo models, and the first thing you always do is push Setup, and that sets up the simulation. So what we have here is an ant nest. That's this purple blob with this red circle in the middle, which is actually where all the ants live. This slider here, population, tells us there's 125 ants, and the other three blobs are piles of food. And what we're going to see is a plot of how much food is in each pile over time. So the ants are going to move out from their nest and look for food. So I'll click on Go, and you can see them moving around. So let me stop the model here by clicking on Go again and point out some things. So you see the little ants moving around. They move around randomly until one of them finds a piece of food. That's a little square here of blue color, or in one of the other piles, and then they pick up the food and take it back to the nest. But as they move back to the nest, they leave a trail of a chemical, often called pheromone, in the real world of ants, and other ants can pick up on that trail. So an ant leaves a trail sort of guiding other ants to the location of the food it found. Now those trails of chemicals diffuse according to this diffusion rate here in this slider. That means they spread out from the original trail across the distance, and they evaporate according to this rate. So the trails evaporate. We stop seeing a trail here. So let me slow it down. This slider gives you the speed with which the model goes. So let me click Go again. They're a little slower here, and you can see these trails being reinforced, evaporating, diffusing. But if a single ant happens to find the food and get back to the nest, and other ants find that trail before it evaporates, then they can follow the trail. And you can see over here the food in each pile going down. Here's the very last pile,